Hello. In this video we're going to be talking about implicit differentiation. And implicit differentiation is used when an equation is not explicitly solved for y. So when we normally have y equals, we say that it is explicitly solved for y, or our f of x, and we use implicit differentiation, implicit being the opposite of explicit, when it is not solved for y. So you can see we have an equation here, x squared plus y squared equals 4. And so what this looks like, if I were to graph it, is a circle that will be centered about 0, 0 with a radius of 2. So that's a rough sketch of what this would look like. And you can see how it's not a function. Now we have the ability in this case to get y by itself. If we wanted to, I could subtract my x squared from both sides. So y squared is equal to 4 minus x squared. And then we would square root both sides, which will require one side to have that plus or minus, because a square root has two different inputs that would work for it. And so we would have plus or minus 4 minus x squared. And I could do the derivative of that. I would have to do it twice, one for the positive and one for the negative. Or we can talk about doing implicit differentiation. Now implicit differentiation just means that we have to do the derivative of both sides of our equation. So we'll do the derivative with respect to x of the left side, x squared plus y squared. Now we'll equal the derivative of our right side, which is 4. Derivative with respect to x of 4. And so what does this look like? Well, the derivative, remember we're allowed to break it down so that we can do the derivative with respect to x of x squared and the derivative with respect to x of y squared equals, and I can already evaluate the derivative with respect to x of 4. Remember, 4 is not changing at all with respect to x, so it's just going to result in 0. Now the one on the very left, the derivative with respect to x of x squared, we've done this hundreds of times, it's just 2x. That's our power rule. Plus. Now this is where it gets tricky. If you talk about what's happening here, we're taking the derivative with respect to x of y, and y is some function of x. So we can look at it like this. We're doing the derivative of y squared with respect to y times the derivative of y with respect to x. So consider it like your chain rule. Y is some function of x that's being squared. So if I think about y squared, I can look at it as, say, some f of x being squared. And so I have the function that's being squared, and then inside that I have another separate function. So I do the derivative of y squared, and then I multiply that by the derivative of y. And that's what's happening over here. And that's still equal to 0. So we have 2x plus, well, the derivative of y squared with respect to y gets me 2y, still times the derivative of y with respect to x equals 0. And I can't do the derivative of y with respect to x because, again, I don't know what y equals all by itself yet. So at this point, all we're going to try to do now is get dy dx all by itself. And so I'll start by subtracting 2x on both sides. And so we get 2y, there we go, 2y times dy dx equals negative 2x. And I'll do my work over here on the right now. When I divide both sides by 2y, so dy over dx equals a negative 2x over 2y. Now the 2's will certainly cancel, and so dy over dx is equal to a negative x over y. And so to read this, we're looking at this as the derivative of y with respect to x, so the derivative of our function y, or equation with y by itself with respect to x, is going to be the same as negative x over y. And so remember that has to do with the slope of the tangent line. So let's pick one of these points on the circle, and I'll choose this one right here. So that kind of creates a 45-degree angle there. So I know that this hypotenuse here has to be 2 because that's the radius of my circle, 2 units. And so each of these side lengths is going to end up being the square root of 2. And you could do the Pythagorean theorem here to check me out. But that makes this ordered pair square root of 2 comma square root of 2. So what is the slope of the tangent line through that point there? And we can figure it out by using this formula. The slope of the tangent line is the same as our derivative, and we would do a negative square root of 2 over positive square root of 2. And so the slope of the tangent line there is negative 1. And I could write the equation of the line if I wanted, so I could say that y minus square root of 2 equals 1 times x minus square root of 2, negative 1 times x minus square root of 2. And so this is the point slope form of our linear equation. That's how implicit differentiation is used, and we are done.